Okay, so we're going to do a reduction of order example. So first of all, we have the equation here. It says for the equation t squared y double naught minus 7t y naught plus 16y equals to 0 for t greater than 0. And then it says here that y1 of t equals to t to the fourth power. And that's very important. So we're going to write that down. So what I like to do is to write this on the side here that y equals to, okay, so this is what you're going to do for every single reduction of order problem. It's basically the same process of every single question. So what we're going to do here on the right side is y equals to v times y1. Okay, so what did it say that y1 was? y1 equals to t to the fourth power. Okay, so we're going to write y equals to v times t to the fourth power. So y equals to t to the fourth times v. Okay, so there you go. So that's step one. Okay, if you got that step one, you're good. Okay, now we're gonna find well, before we do that, let's actually write down the problem here. We're gonna write t squared y double prime minus 7t y prime plus 16y equals to 0. Okay, so what we want to do in this process is to put the y here into the differential equation. However, what's the problem here? We only have y, and we don't know yet what y double prime is or y prime is, so we can't really substitute this in here. So the next step actually is to figure out what is y prime. So y prime, since these are two different they're multiplying, t to the fourth power is multiplying v, so we have to use the product rule. So I'm gonna take the derivative of the first, which is gonna be 4t third. It's gonna leave the second, okay, plus I'm gonna leave the first, t to the fourth, times derivative of the second. Okay, so v prime. Okay, what I like to do is keep the v behind the t so you don't get confused. Okay, so now we have our v prime. That's good. Now what we need to find out is what is y double prime. So y double prime is the same thing. Since this is a plus, that means we have to do the product of this, product rule of this, and then we have to do the product of this. So we're taking the derivative, right? Every time we find a naught, then we have to do a derivative. So let's do this again. So it's going to be 3 times 4, which is going to be 12t, right? And 3 minus 1 is 2, right? Okay, now I'm going to leave the second, plus I'm going to leave the first as it is, and take the derivative of the second. Good. So I just did this right here. Okay, then I'm going to go right here. So I'm going to once again take the derivative of the first. So it's going to be plus 4t to the third. I'm going to leave the second, v prime, plus I'm going to leave the first, take the derivative of the second. Okay, so if you look here, what can we simplify, combine like terms? I see that here's v prime here, and also I have t cubed, and also I'm going to write it in the highest order just so that the v highest order, just so that it's easier for me to read. So I'm going to write this one first, t to the fourth v double prime, and once again I'm writing the t in front of the v because it's much easier to recognize what's going on. So 4 plus 4 is 8t cubed v prime, and then we have the plus 12t squared v. Okay, now we can go ahead and now substitute wherever we see a y double prime, we could substitute this thing in here. Whenever we see a y prime, we could substitute this in, and wherever we see a y, we're going to substitute this here. Now here is the most important detail. You have to substitute these in, and after the substitution, if you still have a any term of v left over, you're doing something wrong. Okay, so after substitution, all of the v's that are not they don't have any derivatives, like they are not v naughts or v double naughts. If there's any v left over, you did something wrong. Okay, and you have to go back and check if that your calculation are correct and if you did the derivatives correct. All right, so let's do that. So we have here first t squared times y double prime. So I'm gonna write t squared. Okay, I'm gonna write y double prime, which is this whole thing right here. So I'm gonna write that t to the fourth v double prime plus 8t cubed v prime plus 12t squared v. Okay, then I'm gonna write underneath it, just because lack of space here, so 7t. Now I'm gonna write whatever we got here for y prime. It's gonna be 4t cubed v plus t to the fourth v prime. Okay, then we're gonna write, so we check that. Now we have to do plus 16y, so it's gonna be plus 16. So this is basically like distributed property. So wherever you see a y, we're gonna write t to the fourth v equals to 0. Okay, so now let's distribute all of this. So this is distributed property, so this has to multiply this. There's a plus, so there's another term, plus, so it's another term, right? So t squared times t to the fourth is going to be t to the sixth. Okay, the v prime stays. That's good. T squared plus 8t cubed is going to be 8t to the fifth power v prime. This is going to be plus 12 t squared times t squared is t to the fourth v. Okay, perfect. Now let's go here. So we have negative 7t times 4t cubed. So it's going to be 7 times 4 is going to be, since it's negative, minus 28. Now t times t to the third is going to be t to the fourth v. This is going to become minus 7t, because it's the distributive property again, right? T to the fifth v prime. Okay, and lastly, it's just going to be plus 16t to the fourth v equals to 0. Okay, so now this whole thing, right, it looks a little disorganized, but you're going to see how everything is going to go away quickly. It's going to look much more organized in a second. So first of all, like I said, you need to get rid of the v. And let's see that if we did everything correctly, the v should go away. So first of all, we have here 16t to the fourth v. Okay. Now we have this minus 28t to the fourth v. Okay. And we also have this 12t to the fourth v. So what's the sum of 12t minus 28 t to the fourth, right? And the 16t to the fourth? Well, the sum of that is 0, right? Because 12 plus 16 is positive 28 t to the fourth, and then we have a negative 28 t to the fourth. So that means that these cancel. Okay, so also, is there any, can I make any like terms, combining like terms? Yes, I can. This, and this. So we have a negative 7t to the fifth v prime, and then we have 8t to the fifth v prime. So the sum of this is going to be, so I'm going to write this first here, t to the sixth v double prime, and then this is going to become 8 minus 7 is just 1t to the fifth v prime, right? Equals to 0. Okay, so then I'm going to take a new piece of paper. Okay, I'm going to write this. T to the sixth v double prime plus 1t v prime equals to 0. Okay, so now we have to solve this differential equation. However, we have a v double prime, right? So our next step, so after we found this out, our next step is going to be, right, w equals to v prime. Okay, so in that logic, if you take the root of w, it's going to be v double prime, right? So then we're going to write t to the 6th w, right, prime, so I'm just substituting this back in, plus t, this should be to the 5th power, t to the 5th power times w, right? Now, what exactly is w prime? W prime is actually dw over dt, right? That's what w prime is. So t to the 6th, I'm going to write this dw over dt plus t to the 5th times w equals to 0. Okay, so then I'm going to solve this using the separables method. Okay, so I'm going to separate them and then differentiate based on what variable it is. So first of all, I'm going to move this here. So we're going to have t to the 6th dw dt equals to negative t to the 5th w. Okay, so I move this here, so minus minus the 0, so the 0 goes away. Now, what I'm going to do here is multiply both sides by dt. What happens when you multiply both sides by dt? Dt goes away on this side, so t to the 6th dw equals to negative t to the 5th w dt. So, as you can see here, the w is on this side, but the dw is on this side, so I'm going to divide by w. So t to the 6th over w dw equals to negative t to the 5th dt. Okay, so then we have to get rid of this t to the 6th. So I'm going to divide both sides, or multiply both sides by t to the 6th over t to the 6th. And if you multiply the reciprocal of t to the 6th, you get rid of the t to the 6th. So we have 1 over w dw equals to, and t to the 5th divided by t to the 6th is going to be negative t to the negative 1 dt, or negative 1 over t, right? dt equals to 1 over w dw. Okay, so now we can go ahead and integrate both sides, this in terms of dw and this side in terms of dt. Okay, so this right here, this w, when you integrate, you're going to get ln of w equals to, since it's negative, it's a constant, it can come out. Okay, so if you take the integration of 1 over t, you're going to get ln of t. Okay, then you're going to get plus c. Okay, now if you raise both sides to the power of e, what's going to happen? You're going to get e raised to the ln of w. That cancels. The e and the ln cancel, so you're just going to get w, right? W equals to, and I'm right here, e raised to the ln t. But notice, if you know your natural logs, you know that this negative here actually is the power of this t, right? So this negative is the power of this t, so e raised to the ln, it cancels the e and the ln, so it leaves of whatever is inside here, whatever is inside in the natural log. So it's going to be t to the negative 1, right? And if you also know your natural log, you know that if there's a plus here, that means that this this plus is actually e to the c multiplying e to the negative ln of t, right? So this is a product here. Although this is a plus, we know that it's actually going to be a product. So it's going to be times c. Okay, so we have t to the negative 1 times c. Now, the next step is, what exactly did we write this w? So, okay, so we figured this out. What's the point? We have w, however, our initial problem, it had no w. Okay, it only had y equals to v times y1, right? There's no w in this first initial problem. So we need to fix that. So we have to go, and we're going to fix that by doing this. W equals to v prime. So that's exactly what I'm gonna write. I'm gonna replace the w with a v prime. V prime equals to t to the negative 1 times c. Okay. However, I don't want to get v prime. I want to get v. So how exactly I'm gonna do that? I'm gonna take v. Okay. V is going to be the integral of t to the negative 1 times c. Okay, and this is going to be integrated in terms of dt. So, what I'm going to do now is v equals to this. So v is going to equal to, now remember the c is going to come out, t of negative 1 dt. So this is the same thing as writing v equals to c of 1 over t dt. And what is 1 over t dt? When you take the integral of this, you're going to get c equals to v equals to c ln of t. And also here we're going to get another constant. I'm going to call this constant k. Okay. So we have c ln of t plus k. Okay, so we found our v, which is awesome. We found our v. So now the last step of this whole thing is goes back all the way here. The first thing that we wrote when we just started the problem. So I'm gonna write it again. Y equals to v times y1. Now, initially we said when we read the problem that y1 equals to t to the 4th. So y equals to v times t to the 4th. Okay, what exactly did we figure out what v was? Okay, so we got v right here. We went all through this whole process. We figured out using separables. Okay, and we figured out what v equals to. So we're gonna write that here. V equals to c, which is a constant, ln of t plus k. K is another constant. Okay, so I'm gonna substitute the v with what I have here. So I'm gonna write y equals to c. You know what? I'm just, for the sake of how we're always write when we do distribute property, I'm gonna write t to the 4th first. So t to the 4th, right? So t to the 4th is gonna multiply whatever the v is, and v is c ln of t plus k. Okay, so t to the 4th, when we distribute, we get y equals to t to the 4th, right? So I'm gonna write this c in front of it, ln of t plus k t to the 4th. So what is our second solution? You may ask, what is the second solution? So first of all, we have, this is our first solution, t to the 4th, and our second solution will simply be, this is going to be y1, y2, t to the 4th, ln of t. And if you notice here, here's constants. That means that a y1 can be 1 t to the 4th. It can be 2 t to the 4th, 3 t to the 4th. Okay, so these are just constants.
Now the same thing for C. It can be 2t to the fourth, 4t to the fourth. We don't know that because we don't have the initial conditions. But we can predict that it's going to be this base of t to the fourth ln of t. That's going to be for sure there. We just don't know what the C is. So we can say that y2 is going to be a constant times this base. Alright, I hope this helped you out, and good luck with your studying.